Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals the square root of x squared plus 6 divided by x plus 3. The first thing to do is find the domain. F of x equals the square root and even root of x squared plus 6 divided by x plus 3. We can rewrite the square root as a fractional exponent. It will be x squared plus 6 to the first power second root 1/2 power divided by x plus 3. The denominator of a fractional exponent is the root. It's an even number here, and the domain of an even root isn't necessarily all real numbers. The domain requires that what is inside of an even root has to stay greater than or equal to 0. So x squared plus 6 needs to stay greater than or equal to 0 here. There is also a denominator, and the domain requires that the denominator cannot equal 0. So x plus 3 cannot equal 0. These are the two conditions needed to be held for the denominator. Starting with the x squared plus 6, to solve for x we can subtract 6 from both sides. So x squared is greater than or equal to negative 6. We can then take the square root of both sides. The square root of x squared is greater than or equal to the square root of negative 6. The square root of x squared is the absolute value of x, and it's greater than or equal to the square root of negative 6 is not a real number. And since the domain is made up of real numbers, and we're comparing this against something that's not real, this inequality does not matter to the domain. We can now work with the x plus 3. We can solve for x by subtracting 3 from both sides, and the x does not equal negative 3. This is the only condition needed for the domain of real numbers. So the domain will be all real numbers except negative 3. So the domain will begin at negative infinity. It'll go up to negative 3, not including negative 3, round bracket, union, beginning again at negative 3 up to positive infinity. So the domain there is all real numbers except negative 3. It has all the numbers to the left of negative 3 for the first interval and all numbers to the right of negative 3 for the second interval. Negative 3 here will represent a vertical asymptote because it's in the denominator, and that's what's making it not equal to 0, is x not being that negative 3. The next thing to do is find all critical numbers. We will take the first derivative. F of x is a quotient of expressions here, so the first derivative will involve the quotient rule. So f prime of x will equal the derivative of the numerator, which is a power rule. Bring down the power. Leave the inside alone. Subtract 1 from the power. I will call that 2 halves. Multiply by the derivative of the inside to complete the chain rule. All that's the derivative of the numerator times the denominator left alone minus the numerator left alone times the derivative of the denominator, which is a 1, and then the entire thing over the denominator squared. The first term in the numerator, we can collect the constants together. There's a 1/2 and a 2. Those can multiply. 1/2 times 2 is 2 halves, or 1. There's also an x and an x plus 3 that can be moved to the front that are multiplying each other. So x times x plus 3. And then there's an x squared plus 6 to the 1 minus 2 negative 1/2 power. And then minus the second term in the numerator is an expression times 1. Anything times 1 is that same thing. So it'll just be the x squared plus 6 to the positive 1/2. and it's over the denominator that we will leave alone because the denominator is already in a factored form. The first term in the numerator does have a negative power, so we can move that to the denominator of the first term and get a common denominator between the first term in the numerator and the second term in the numerator. That's one option. Or another option is to factor out the common factor, because there is a common factor of x squared plus 6 to a power. Either version works. Factoring can be a little bit easier to work with. We have a power of x squared plus 6 in each of the terms. We can factor out the lower power of the two. That will be the negative 1/2. So we can factor out an x squared plus 6 to the negative 1/2 power. Factoring is division, and division is subtraction of exponents. So by factoring out a negative 1/2 power, we will be subtracting a negative 1/2 power, which is equivalent to adding a 1/2 power. If we add 1/2 power to negative 1/2, that becomes a power of 0, and anything to the power of 0 is a 1, so all that's going to disappear to be a 1. If we subtract a negative 1/2, which is add 1/2 to this, 1/2 plus 1/2 is 1, and this will go to the first power, and we will have that entire expression in parentheses to the first power for the second term. So there's what should be left. The first term should have an x times an x plus 3, and the second term should be minus x squared plus 6 in parentheses. There is still a negative power in the numerator, but now it's been factored out, and so it's a negative power on the entire expression in the numerator, and so it can move to the denominator of the entire fraction, down with the x plus 3 squared, to become a positive power. Inside the square brackets, we can distribute the x in to the x plus 3, which will be x squared plus 3x, and the minus in to the x squared plus 6, so minus x squared and minus 6. And all of this will be over x squared plus 6 has moved down to the denominator to become positive 1/2 power, and x plus 3 quantity squared. We can combine like terms together in the numerator. The x squareds will cancel each other out. There will be a 3x minus 6 after these are canceled out. We can rewrite the 1/2 power as the square root of the x squared plus 6. And then we have x plus 3 quantity squared. We want to fully factor the first derivative. The numerator has a common factor of 3. Everything else is factored as much as possible. Factoring out the common factor of 3 will leave behind an x minus 2. And all of this over the denominator of x squared plus 6 and x plus 3 quantity squared. So the first derivative written as a single fraction. Everything is to a positive power, so we can now set the numerator equal to 0 and the denominator equal to 0 and solve for all x's. Starting with the numerator, 3 times x minus 2 equals 0. We can divide by 3, so just x minus 2 equals 0, and we can add 2 to both sides, so x equals 2. Now working with the denominator, we have 2 factors in the denominator multiplying each other that are equal to 0. They can separately be set equal to 0. Starting with the square root, we can square both sides. Square root and square cancel each other out. We can subtract 6 from both sides, so x squared equals negative 6. We can take the square root, and x will become plus or minus the square root of negative 6, which is plus or minus what is not a real number. Now to work with the x plus 3 quantity squared, the first thing we're going to do is take the square root of both sides, because the square root of square will cancel each other out, and it will become just x plus 3. The square root of 0 is 0. We can then subtract 3 from both sides, and x will equal negative 3. We now want to check to see which of these are in the domain. The domain is all real numbers except negative 3. The first value, x equals 2, is a real number. It's not negative 3, so it is in the domain, so we keep it. The next one, x is not real numbers. Well, our domain is real numbers only, so we do not keep that result. And then the third one, negative 3, is not in the domain, so we do not keep that one. So x equals 2 is the only critical number here. We can now draw a domain line, a line representing the domain. The domain is all real numbers except negative 3. Negative 3 will represent a vertical asymptote, so we can put it as a dashed line, breaking up the domain into two separate intervals. We can put any critical numbers on here. We have x equals 2 as the only critical number. It'll be to the right of negative 3 since it's greater than negative 3. And this further breaks the domain up into now 3 intervals. We can pick a test value in each of these intervals. The first interval is negative infinity to negative 3. Negative 10 is in that interval. The next one is negative 3 to positive 2. 0 is in that interval. And the next interval is positive 2 to positive infinity. Positive 10 is in that interval. We can test the trend in each of these intervals by plugging these test values into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. So the best place to plug into is the fully factored version of the first derivative. That will be this one here. A couple things about this. In the denominator, there is a even root, and what's inside that even root already has a condition for the domain back up here that it has to stay positive. And the square root of a positive number is a positive number, so that root in the denominator is guaranteed positive due to the domain, and we're in the domain here. The second expression in the denominator is quantity squared, and quantity squared will always be positive. So the full denominator is positive here. In the numerator, there is a positive 3. That's a positive. Therefore, everything is positive except for x minus 2, which depends on the x value, whether that's positive or negative. So the first derivative being positive or negative solely depends on x minus 2, and therefore we can plug the test values into just x minus 2. Starting with the first test value of negative 10, plugging in for x minus 2, negative 10 minus 2 is a negative number. So we have a negative first derivative, which corresponds to a decreasing trend. We can now plug 0 into the part of the first derivative that matters. 0 minus 2 is a negative number. We have a negative first derivative. This corresponds to a decreasing trend. and then plugging a positive 10 in. 10 minus 2 for the part of the first derivative that matters is a positive. We have a positive first derivative. This corresponds to an increasing trend. So we have a decreasing interval from negative infinity up to negative 3, the vertical asymptote, and then union, because it is happening again, from negative 3 up to positive 2. Those intervals cannot be put together because the negative 3 is not included in either of them. We have an increasing interval happening starting at 2 and going to positive infinity. X equals negative 3 here is a vertical asymptote, so it is not a critical number. The only critical number is x equals 2. Now right at that critical number of x equals 2, we have a trend change of decreasing to increasing. That's going to make x equals 2 be a relative minimum. So we have a relative minimum occurring at an x-coordinate of 2. It'll have some corresponding y-coordinate that can be found by plugging the x-coordinate of 2 into the original function. So the y-coordinate will be f of 2, which is going to be the square root of 2 squared plus 6 divided by 2 plus 3, which is the square root of 2 squared is a 4, and 2 plus 3 is a 5. So this is going to equal the square root of 4 plus 6, which is a 10. Over 5. So it has a y-coordinate of the square root of 10 divided by 5. So we have 2 decreasing intervals, 1 increasing interval, and a relative min at the coordinates of 2, square root of 10 over 5.